Hello everyone, welcome back. Today we will be going over interrupt controllers and discussing exactly what they do and accomplish in operating systems. The last video I spoke on was about operating systems and involved with interrupts and interrupt service routines. This video will be going over next important parts involved with interrupts, so let's begin. Okay, so our next topic is the role of interrupt controller. So the interrupt controller is responsible for managing multiple interrupt requests, which is short for RRQs, and ensure that they are processed efficiently. It prioritizes interrupts and decides which one should be handled first, and then directs them to the CPU, which will prevent conflicts and ensure a smooth execution. So some key points to consider are the interrupt prioritization. So this will determine which interrupts has the highest priority when multiple interrupts occur simultaneously. And next we have interrupt masking and enabling. So this will allow certain users to be enabled or disabled to prevent interference with critical tasks. And next we have efficient CPU handling, which will reduce the CPU's workload by managing and routing interrupts systematically, ensuring a smooth operation. So our next point is managing and prioritizing interrupts. So efficient interrupt management ensures that critical tasks are handled first while lower priority tasks wait. This can prevent system slowdowns and ensures real-time responsiveness. And interrupts are managed through software and hardware techniques like prioritization, masking, and nesting. And some points to consider are the interrupt priority levels. So the higher the priority level are handled first, while the lower priority ones wait until the CPU is free to then move on to them. And next we have interrupt masking, and this can make that certain interrupts be temporarily disabled to prevent conflicts or ensure critical tasks are completed first. And then next we have a nested interrupt handling. So this will mean that some systems allow higher priority interrupts to preempt lower priority ones, ensuring that the urgent tasks are not delayed because of this. So our next topic will be exploring the common interrupt controllers, the architecture, and the features. So interrupt controller architectures include various features that enhance system efficiency, responsiveness, and the scalability of it. So these features ensure that interrupts are handled correctly, prioritized, and routed to the appropriate processor when necessary. So some points to consider are the priority-based interrupt handling. So this will assign different priority levels to interrupts, ensuring that critical tasks are executed first. Then we have interrupt vectoring, which means that each interrupt has a predefined address, allowing the CPU to quickly locate and execute the corresponding ISR. And next we have scalability and multiprocessor support, which basically means that advanced controllers like an APIC distribute interrupts across multiple processors for better loading balance and system performance. So next, our topic is how do interrupt controllers help to handle interrupts? Well, interrupt controllers play a crucial role in managing interrupts efficiently by organizing and directing them to the CPU. They help prevent overload, ensure smooth execution, and allow systems to function without unnecessary slowdowns or conflicts. Some key points to consider are that it can reduce interrupt latency, which means that ensures that a higher priority interrupts are processed quickly, preventing delays in time-sensitive tasks. And next we have it can support multiple interrupt sources. So it will allow multiple devices to generate interrupts without overwhelming the CPU. And then lastly, it can handle different sources of interrupts. So it can detect and ignore false or unnecessary interrupt to maintain system stability. And with that, we have reached the end of our slide. I want to give a quick thanks for staying till the end. Hopefully I gave some insight and tips to learn about interrupt controllers and what they do and provide. It can be a lot of information to process and get through, but thanks for watching, and please feel free to like, comment, share, and subscribe, and have a good one.